students, and welcome to today's lesson. I'm Ms. Lee. Today we'll explore the question, why do shadows change during a day? Are you ready? Grab your pencil and your science journal, and let's get started.
My family and I went on vacation in St. Louis, Missouri. Look at this photograph from our trip. This large structure is called the Gateway Arch. Do you notice the position of the Gateway Arch's shadow? Where do you think the sun was when this photograph was taken? Do you think the sun is up in the sky because it is daytime? Good thinking. Now look at this new photograph. Look closely at the two photographs. Let's call this photograph figure 1 and this photograph figure 2. How are figure 1 and figure 2 similar? Well, both photographs show the Gateway Arch and its shadow. And hey, in both pictures, I can see the same lawn, trees, and river in the background. So the camera is facing the same direction in both photographs. So how are figure 1 and figure 2 different? Look at figure 1. The shadow is longer and can be seen over the river. But in figure 2, the shadow is mostly on the grass and looks like it is almost directly under the arch. In figure 1, you cannot see the full shadow of the arch, but in figure 2, you can see the full shadow of the arch. How can the same object make different shadows? I think what the shadow looks like depends on where the sun is. Do you agree? The sun appears to move in the sky, and the position of the sun causes shadows to change during the day. Fascinating. But I wonder, why might the sun's position change an object's shadow? I think the shadow changes because the light comes from different directions when the sun moves. The same object might block light differently when the shadow moves. By looking more closely at light's role in forming shadows, we can begin to better understand the question, why do shadows change during a day? Let's make some observations to help us explore why shadows change during a day. We can use this light bulb as our light source. Let's use this notebook to help us as well. I will set the light bulb here and the notebook here. Now let's turn off the overhead light. Watch the cover of the notebook as I turn on our light source. Ready? If the light from the light source reaches the notebook, give me a thumbs up. If the light from the light source does not reach the notebook, give me a thumbs down. Is your thumb up? If so, great job. How do you know that light from the light source is reaching the notebook? Well, when the light bulb is off, the notebook is dark, but the notebook is bright when the light bulb is on. The light source illuminates the notebook. Do you notice that when the light comes out of the light bulb, it goes in all directions? I noticed that too. How could we model light coming from a light source in all directions? I know, our light source could be like the sun, and we could draw lines of light coming out in all directions. The light source emits light. Emit means gives off. When a light source emits light, it gives off light. Let's document our learning with a light model. First, let's draw a light source. Light sources emit light. Let's draw some lines coming from our light source. These lines represent light rays. A light ray is a model of light that represents the direction light can travel. The light rays on our light model travel out from the light source. How would you describe the path of a light ray? Did you say that a light ray travels in a straight line from a light source? I agree. Light rays travel in straight lines from a light source. Let's add this information to our light model. We can write, a light source emits light rays that travel outward in straight lines. Great. I wonder how light rays are involved in forming shadows. Maybe we should observe a shadow forming. Let's use our light bulb and notebook again. But this time we will place a pencil between the light source and the notebook. Ready? Wow, look at the pencil shadow. How does the pencil shadow form? Some light rays from the light bulb hit the pencil. Those light rays do not hit the notebook. The pencil blocks light rays from reaching the notebook. Let's look back at our light model. How can we represent what happens when light rays strike an object such as a pencil or a notebook? I know. We can make the light rays stop at the object. Now let's add to our explanation. A shadow forms when an object such as a pencil blocks light rays from reaching a surface. Let's look at the Gateway Arch again. Imagine the light rays that form the arch's shadow in this photograph. We can use our light model to help us. How would you draw light rays on this photograph to show how the shadow forms? Do you think we would draw light rays traveling down from the sun in straight lines? I do. Some of the light rays would reach the ground, but others would be blocked by the arch. We saw these two photographs of the Gateway Arch at the beginning of our lesson. How would light rays help explain the arch's changing shadow? Maybe light rays from the sun hit a different part of the arch when the sun moves. Do you think the light rays come from a different direction when the sun moves? Maybe that's why the shadow changes places and gets longer. We are still not sure about the arch's changing shadow. Let's design an investigation to determine why the sun's changing position causes an object's shadow to change. These objects are our investigation material: a lantern, a pencil, and modeling clay. A lantern is a light source similar to the light bulb we observed. Like the light bulb, the lantern emits light in all directions. When the lantern is close to the pencil, a shadow of the pencil is formed. I think we can use these materials to help us investigate, but we still need a testable investigation question. What are we trying to figure out? Well, we want to investigate why the sun's changing position causes an object's shadow to change. So let's ask, how does the position of a light source affect the length of the shadow? How will we use the light source to change the shadow length? Let's think about possible variables that might affect the length of the shadow. Do you think we can change the angle of light? I think so. We can hold the lantern at different angles. We can check the angle by comparing the direction of the incoming light with the horizontal surface. Look at the protractor. Do you see 0 degrees? It's here. If we hold the lantern like this, the light source is at 0 degrees. Do you see 45 degrees on the protractor? 45 degrees is here. How should we hold the lantern to get an angle of 45 degrees? Yes, like this. The light source is at 45 degrees. Finally, look for 90 degrees on the protractor. Now I see 90 degrees. Let's hold the lantern like this so our light source is at 90 degrees. What other variables can we change? We can change the distance between the lantern and the pencil to see if it affects the length of the shadow. And we can even change the side of the pencil lit by the lantern. Let's investigate each of these variables: angle of light, distance of light, and direction of light. Let's use our testable question, materials, and variables to develop an investigation plan that meets the criteria of a FAIR test. In order to design a FAIR test, we should change only one variable at a time, the variable we are investigating. By conducting a FAIR test, we can observe each variable one at a time and then compare the variables. Multiple trials are important because we need to try a test more than once to make sure our results are correct. For your task today, you will design an investigation plan that meets the criteria of a FAIR test. I'm so excited to find out the results of our investigation. Let's review your task for today. Design an investigation plan that meets the criteria of a FAIR test.